Hello, and welcome to this video to accompany our work, Centralized Collision-Free Polynomial Trajectories and Goal Assignment for Aerial Swarms. We consider the problem of central planning of trajectories for multiple interchangeable aerial vehicles. Trajectories are piecewise linear in space with vehicles only moving in straight lines vertically and horizontally. Trajectories are also piecewise polynomial in time, which allows physical aerial robots to track them easily. Our approach is computationally efficient, allowing us to plan trajectories for more than 1,000 agents at once, as shown in this simulation. In our approach, we assign agents to goals based on initial trajectory plans, then refine trajectories by resolving collisions. To validate our approach on real hardware, we plan trajectories for up to 24 quadrotor vehicles. In this experiment, we have 24 vehicles moving from a grid to an O formation. Collisions are resolved using two methods. In the first, we make agents wait in a holding altitude before beginning horizontal motion. In the second, we send agents to different altitudes and all vehicles move horizontally at the same time. In both cases, we leverage the ability of aerial vehicles to hover and move at different heights. In the experiments shown, we resolve collisions using time delays. In this experiment, we have 20 vehicles moving from a grid to an X formation. In these three experiments, 16 vehicles spell the letters UTD representing our university. Thank you for your time and attention.